Am I visible camera?
Yes, sir.
Okay. Because here I can only see the PPT, not my camera. So I thought. We will wait for another 5 minutes because people might be traveling. And then, by the time, if anyone has anything to discuss, please share. Please discuss. You can. So that I can put more emphasis on that point if they have particular query. Okay. Suryavanshi sir will not be able to join because he's stuck in traffic. Right. So without him, we can start. We can proceed. So let us wait for some more faculty member to join. Yeah, I think we start. There's no point in waiting.
Hello?
Yeah, please start session.
Okay, so
HOD sir will not be there. HOD sir will not be there.
HOD sir is not there today.
Yeah,
Okay, sir. So shall we start then?
yeah, you can start with the normal introduction.
Okay, sir. So good evening, everyone. Energy Club of DBIT welcomes you all to our webinar on energy conservation opportunities for hotels, residential and commercial buildings. In this webinar, we will be learning about how energy consumption can be estimated, how do we select proper fuel for a particular application, and also some energy conservation methods for ceiling fan and light, air conditioning, refrigerator, chillers, pumps, and water heaters. We will also be learning about the solar energy systems and how to enhance the power factor. So before we move to the speaker, I would like to introduce you to our today's speaker for the session. We are very lucky to have him today. I would like to introduce Dr. Yogesh Parya. He has completed his PhD from IIT Bombay, also has filed two patents which are related to condensers and heat exchangers. He is specialized in desalination, humidification, dehumidification, refrigeration, and energy fields, and he also has carried out multiple energy audits and energy conservation projects in across the nation, like in Viraj Industry, Mukund Steel, Cadbury, and many more. So, without any further ado, I would just like to hand over the session to our speaker, Yogesh sir.
Okay, a warm welcome to everybody. Uh, I hope I am audible. If there is any noise
Yes, sir,
interference,
you're audible.
okay. Otherwise, I can put up my fan. That is going to cause some noise. Is it clear noise? Is it okay? Okay. So, guys, no, there is no one is in line. I am not finding anyone who is waiting. Is it anybody waiting? No. Yeah. Okay. So, no, okay. Now, yeah. Okay. Guys, so the topic of today's discussion is energy saving opportunities for hotels, residential, and commercial buildings. Now, uh, why we need energy that everybody knows. And Rajesh, why we need energy? We need energy for various purpose like a ceiling fan, light, air conditioner, refrigerator, chillers, pumps, water district. Obviously, chillers and pumps may not be available for residential purpose, but it is largely used in commercial complex, malls, hotels, and many more things. Okay, I just add how to control this because this is going to keep on adding. Okay, sorry. Now, uh, we know that in our home we are using electrical energy for running lights, fan, AC, refrigerator, and bathing purpose. At the same time, we also use thermal energy for cooking, water heating, and air heating application. Let us first have some glimpse of why shall I study this topic? What is the importance to that? Is it really matters that if I consume more energy? Let us take an example that if by chance you are able to save 5 kilowatts out of your total electricity load, if you are able to save 5 kilowatt of load by switching off some light, by switching off, by changing the pumps, or by doing some AC repairing or anything. So, so 5 kilowatt in 24 hours, it means 120 watts per day. You are 120 units you are per day saving. 120 units per day into 365 into 10 rupees. that it means you are actually saving 4.38 rupees lakh per year. This is just a small number which is very much easily possible for any person to save 5 kilowatt of load. In industry, this number 5 may be ranging to 500 kilowatt. When we do audit, we have a capability that we can even save 500 kilowatt. So then you can assume that this number goes around 438 lakhs rupees per annum. So industry can save in the range of 5 crore 6 crore rupees. At the same time, if you are able to save some amount of LDO means light diesel oil. We know coal, we know petrol, we know diesel. But these are not the only fuel which are available. There are various fuels which are largely used in industry, so that we will discuss in my slide. But let us assume that if by chance we are able to save 50 liters of oil per day, then 50 liter into 300. Now today's rate of LDO is 81 rupees per liter. This is not HSD, this is LDO. HSD is costing you 91 rupees and LDO is costing 81 rupees per liter. So if in it by some measures, if you are able to save 50 liters per day liter of the oil, then you can save 12 lakh rupees per annum. Okay. Now let us go for the calculations of your light bill. First of all, you shall know that how the electricity bill is being calculated. Let me tell you a simple calculation that 1 kilowatt hour means 1 unit. What is 1 kilowatt hour? Kilowatt, whatever is the load, into operating hours. That becomes kilowatt hour. 1 kilowatt hour means 1 unit. So it means that if a geyser having a load of 3 kilowatt, if it runs for 2 hours, then 3 into 2 becomes 6. It means a geyser running for 2 hours in a day will consume 6 units per day. At the same time, the fan has a power or consumption of 70 watt. As compared to this number is too small. It means that if the fan runs for 12 hours in a day, it will consume a less than 1 unit per day. It means it is after, so you calculate how many tube lights you have, you calculate how many fans you have, you know how many refrigerators, how many air conditioner, how many geysers, which fan, how much time it runs, you just tabulate it. And then approximate time you write down. This into this much. So this will give you and this much unit consumption per day. Into 30, this will be around whatever numbers come. So 600 units will be consumed in a month. You can cross check your light bill by this table. I hope it is understood. And any doubt in between, you can ask question. Now, this is about a consumption of electricity you are having. Now, but I am not interested. I am not interested in. I'm not interested in knowing my electricity bill. I am interested in saving the light bill. So, how to do that? Now, you know that the conventional fan is using AC motor. Nowadays we have a DC motor. It is called as brushless DC motor. This, if you use a fan having BLDC motor, then the power consumption of that fan at different speed will be maximum 30 watt. While the ceiling fan at different speed, power consumption may be 80 to 80 watt, 80 to 85 watt. It means as compared to BLDC fan, the power consumption is almost double than this fan. So I don't say that you replace the conventional fan with BLDC fan because the fan cost is around 3,000 rupees. So saving is not that attractive. But in case you are going to purchase a new fan, better you purchase a BLDC fan, right? So if you purchase a BLDC, if you purchase BLDC fan, then the power consumption instead of 70 to 90 watt, it will drop to 28 to 38 watt. So your energy bill will proportionally be reduced by 40 to 50%. Right. Now, lights. Lights, there are n number of lights available. You know the names of the lights. There are CFL lights, there are tubular, there are fluorescent light, there are incandescent light, there are LED bulb, there are halogen bulb. So many types of lights are available. So which type of light I shall choose? Then you have to select some factors, that lumens per watt. How much light that, how much lumens I can get per watt. Similarly, there is one term called as color rendering index. It means that whether my object color remains same as it was original during this light. Yes, then the color index is 100. Otherwise, you might be finding that the color of the uh, material or object changes as the light quality changes. So in cloth business, they have to choose the light having CRI 100, because if they if they go for light having CRI something different, then the actual color of the cloth may be different as than it is. Okay. Second, life and cost. So these are the three factors you shall first look into, and accordingly you shall choose the light. Then you shall also know that for what application I want the light, whether I want for a precise work, whether I want only for study purpose, depending on the my application, or I want for street light purpose. Depending on the application, you can choose the light. Then obviously you will choose a light having a payback of less than a year. Then now these are the selection of light. After selection, whatever lights you are using, sometimes lights are being simply put up on the walls without reflectors. So put proper reflector and control so that all the lights which is being actually absorbed by the walls and all that thing will not get wasted. So the maximum light will be used where it is wanted. Use lumen sensor or on motion sensor. Sometimes it happens that lights and fans remains on without the person is available. So it is better to put it off. If you can't do it, put the sensor based all controls. Because of this, light will be turned on and off depending on the requirement. Second, one second. Second, you can optimize number of operational by using LED light, and sometimes the lights is available in natural. Windows are there. There are some. So if you can get the light by natural means, try to avoid the use of light when daylight is available. These are the simple things which you know, guys. So I'm not going to put more stress on this. How to measure the light level? So this is called as lux meter. Lux meters are available in the market. The range, the cost of that may be ranging between 2,000 to 10,000 rupees. Then how many lux I wanted, that is generally being fixed, that if you are just walking, then you may require a light level of in the range of 30 to 100. But if you are going to working at some place in a control room, then you require a light of maybe 200 to 500. So the amount of light intensity, like a person who is cutting the diamond, there the light intensity has to be more, because even a small mistake will turn to a heavy loss. Now, just giving you some glimpse that how much lumens are being produced per watt, you can assume that the incandescent bulb, which is used for quite long back, are just producing 8 to 18 lumens per watt consumption, while this number is pretty high in case of fluorescent lamp. In case of CFL, it is still almost same range. So, which light you are using depending. So, if you use low potassium, if you use low pressure or sodium bulb, it gives more light per watt consumption. However, its CRI is very less. So, it is used for the roadways, for tunnel, canal, because at this place I I don't mind even the color of the object being changed. And these are the light of those bulbs. So you can see on the street such kind of bulbs are majorly used. So again the same study you can get this. Now we'll focus on air conditioning. I think everybody knows about air conditioner, how it works. Is there anyone who don't know about AC? Okay. Now, air conditioner is a device which actually takes the heat from the room or from the object and deliver to atmosphere. So the purpose of the AC is to pick up the heat from the room and deliver to atmosphere at a higher temperature. So this temperature is suppose 25. This temperature may be 40. So I have to then to take the heat from here to here. I am passing a cold fluid having temperature less than the ambient temperature. So the air when passes over the cold coil, the heat of the air is rejected to the inside fluid. Inside fluid is is being compressed. Its pressure and temperature increases to the extent that it is higher than the atmospheric temperature. So now the heat of this gas is rejected to atmosphere and it comes back. Again pick up, throw, pick up, throw. So this is how the cycle operates in an AC. So in the AC there are four components: evaporator, compressor, condenser and expansion. Now if you want that the AC shall consume less power, then this condenser shall be of such a size that the amount of pumping required shall be less. So I am consuming power here because my condenser is unable to reject the heat. So if I provide large surface area in the condenser, then this compressor will require less amount of power consumption. Or if the ambient temperature is less, then the compressor will require less power. Are you getting point? So let us see this with the graph. So this is your AC inside room and this is your outdoor units. So you can see that if the compressor power is being increased, then the actual power consumption from, suppose I have my condenser operating earlier at this temperature. Now it has been increased to this temperature. So it means that I have to compress from here, not from here to here, I have to compress from here to here. So it means that the compressor power consumption will increase. So it is better that now this will happen because your condenser coils are dirty. If the condenser coils are dirty, then the refrigerant will not be able to exchange the heat with atmospheric air. So it means that if you clean this condenser regularly, then the amount of pressure required will be less, so compressor will be consuming less power. So it is better to clean the condenser coil more frequently, as and when you have time. Keep on cleaning at least once in a month. That will be good practice. Select a 5-star rated AC. In 5-star rated AC, the condenser has large area as compared to less star AC. Then you operate at a temperature of 24 to 26 because there is no point in operating at 18 to 20 degrees Celsius. That is increasing the heat load on the room, and then your AC will operate for longer time. It means more power consumption. Okay. Now let us take some glimpse that if I choose which AC I shall choose. Shall I choose 1-star AC? Shall I choose 5-star AC? When you go to a shop, you have option of selecting AC from 5-star to 1-star. Obviously, the cost of 1-star AC is less, and the cost of 5-star AC is more. So now it is a trade-off. Shall I go for 5-star or not? Now let us assume if you are going to purchase a 1 ton AC, and if you know that I am going to use my AC 10 hours per day, and I am not going to use it throughout the year. I am going to use it hardly 150 days in a year, because in a winter I don't need my AC, or in summer, or in any season I may not require AC. Hello, is my voice breaking? Okay. Now, if these are my operating conditions, then if you select a 5-star AC, then its power consumption will be 1 kilowatt approximately. And if you choose one a 1-star AC, the power consumption for the same AC will be 1.3 kilowatt. Now, 1.3 kilowatt AC, if it is going to run for 10 hours in a day, 150 days in a year, so this into this will be this much units per year. So 5-star AC will consume 1500 units, while 1-star AC will consume 1900 units. Now this into 10 rupees, that will be some bill. This into 10 rupees, that will be something bill. So obviously 19,000 rupees will be the bill. Here the 15,000 rupees will be the bill. It means you have saved 4,000 rupees per year as compared to 5-star. Why you? So similarly, if you go for a 2-star, saving will be less. If you go for 3-star, saving will be less. If you go for 5-star, so it is better to go. So in this case, my saving will be. It means that I am going to consume my power consumption will be minimum. Now, if the cost of this AC is more than 4,000 rupees or less than 4,000 rupees. Suppose now this AC is costing me 30,000 rupees, and this AC is costing you 25,000 rupees. You have saved how much? 5,000 rupees, but you are wasting 4,000 rupees per year extra. It means that after 1 year, you are paying this much every year. But if you have purchased this AC, then although you have paid 5,000 rupees extra, within 1 year you have recovered that cost, and from next year you are saving 4,000 rupees annually. Now, before going for this, I will say, do you know about this? This is reflecting foil put on the glass. What will happen because of this? Because of this, the all the sunlight, which is actually a window glass, is being a plain glass. Through this, sunlight directly comes. It has a transmittivity of 80% to 90%. It means all the sun energy is directly coming to my room, and it is increasing the heat load of the room. So if I put a reflective foil on the room, all the sun energy falling on the glass will reflect it back than being entering in. Because of this, although the visibility will be down, but the heat load on the AC will reduce. Let us see how much I can save. Suppose you know that the average solar radiation is 1000 watt per meter square. It means that if you have a window of 1 meter square area, 1 by 1, then through that 1000 watt load will be added through sun. Now, you know that this sun intensity is being varying over the day. So I say that 2 kilowatt hours per day will be added from sun. This is equivalent to 0.6 TR load added to your AC. It means that 0.70 kilowatt of the electricity being consumed per day extra per meter square of the window. So it means 9 rupees per day you are losing. If the AC is operating 120 days per year, and so accordingly, and my window area is suppose 200 meter square, it means I can, by putting the foil, 2 lakh rupees I can save. And the cost of the all the foil is hardly 30,000 rupees. So it means that within 2 months, I am going to recover my cost. Okay. Now, guys, are you getting? Is there anything that I have to reduce my speed? Please speak up. Okay. Now, how to reduce the power consumption of your air conditioner? All the ACs has to be operated at 24 to 25 degrees Celsius. In some countries, it is being all the remotes which are coming has a locking mechanism that you cannot set the temperature below this. In some hotels, it is being implemented even in India. So, because customer has a habit of reducing the temperature to 80 degrees Celsius and then using a blanket and sleeping. That is actually not a good habit. Okay, then you can check the sensor operation, whether it is been operating properly or not. Sometimes sensors are not working. Because of that, the AC continuously keep on running without, even though you are in dark sleep, AC is on. Sometimes sensors are being malfunctioning, so check your sensors are properly working or not. Reduce the heat load by, so that all the glasses shall be put a reflective foil. If not, put the curtains off. The curtains has to be put not inside the glass, inside the room, outside the glass. Then avoid excessive lights and fan. Optimize fresh air infiltration. Sometimes we are sleeping in the home and the doors is kept open, or the door is just latched, or it just kept light open. Because of that, some air infiltration may occur. Clean your ACs periodically, and use the AC having a power consumption 0.9 to 1.15 kilowatt per hour. If this number is coming, then you can say your AC is working properly. Now, let us come to a refrigerator. Refrigerator is, some of my friends are saying their light bills are coming 5,000 rupees to 6,000 rupees per month. They say that we are not using AC, we are only fans, but we don't know why the light bills are coming so high. The first mistake, that you are keeping your fridge close to the wall. Once you are keeping your fridge close to the wall, then you know that in a fridge you have a evaporator, condenser, compressor. Now you know that through this condenser the heat is ejected to atmosphere. Now if this unit is placed just close to the wall, the air circulation will be less. Once the air circulation will be less, then the temperature of the air will be much more increased. If the temperature of the air will increase, the refrigerant pressure will be increased. When refrigerant pressure will increase, compressor has to do more work to push the energy to ambient. It means that if you just keep a gap of 1 feet, then air circulation will be maintained, and there will be some less, then the power consumption can be reduced. This you can check at your home. You can purchase this device. This is called as power guard. This power guard is costing you 2,000 rupees maximum. If you just plug you can measure the power consumption of your all devices, and you can then check the power consumption of your fridge over the day, how much power has been reduced. You can check. Second, the condenser coil can be of this type, which is quite old ACs if you have old fridge. But nowadays you are finding that the fridge fridge backside is totally closed. There, the condenser coil is placed somewhere here. It is compact coil. Now through this coil, an air is passed. It means that this coil's surface area is being shrink down to this and it made a compact. Now, obviously, this fridge again being kept close to the door, so the air is not coming and air is not going, so less amount of air circulation occur. Right. Now let us see. Sometime our freezer is, you can see the freezer could be like this. It means you can find the ice being formed on the freezer. Once the ice is formed, the heat transfer from the media to the gas will reduce because this is acting insulator. So inside temperature will reduce further, and then heat will transfer. It means now my compressor has to do extra work from that temperature to condenser pressure. So this has to be removed periodically. That is called as what? Defrosting. It is frosting and defrosting. Whether your defrosting is being properly working or not, it's sometimes the sensor which is placed on the coil may be dislocated, may be get not functioning well. Because of that, you may find a big frost and maybe you have avoided. So after a month when you are checking, by the time your energy bill has been already gone. So it is always better to keep the track of whether sensors in the fridge are working properly or not. So misplaced sensor, damaged condenser coil, dusting on the condenser, frosting, improper air circulation, inefficient motor or compressor. This could be the reason of higher power consumption in a fridge. I just wanted to show you some photograph of a condenser coil which we have seen. Right, the condenser coil is placed outside, and you know that it is being, your kitchen is being cleaned periodically. Because of that, all the dirts, sometimes some dirts get accumulated on the coil. Now in this case, if the coil is trying to reject the heat to atmosphere, how can it reject? Because this is already choked. Once it is choked, you cannot throw the heat. Then the compressor has to do extra work to do it. This temperature will be too high. Now, guys, we are coming to, as a mechanical engineer, we shall know that in a commercial building, wherever you go to malls, hotels, you don't find a split AC. But you find your entire mall is air conditioned. Now, in that case, they are using a chilling plant. There, in this case, my cooling is by air. It means the refrigerant is cooled by air. But here, the cooling is because of water. So I have my evaporator coil, and on second I have a condenser coil. Through evaporator, I am passing a water. Water is coming. Hot water is coming, is getting cold. Now this cold water is going to AHU. I will tell you how the AHU will work. And here in the condenser, the cold water is coming and getting hot. This hot water is coming to a cooling tower. Through cooling tower, the water is being sprayed, and once it's sprayed over the cooling tower, then the water gets cooled. So there are pump set being placed all around. Now, let us see the functioning of a chiller. Chiller has evaporator, condenser, compressor, and expansion valve. Through the evaporator, I am circulating a water. This cold water will go to an AHU. In this AHU, you have a fan coil unit. These are the coil having the fins. Through this coil, cold water will go, and it will get heated, will come. Now, I am passing an air. The air will come when the air will pass over the coil. The air heat will be absorbed by water and air will get cold. This cool air is supplied to the room. After the room, it picks up the heat. This heat is coming back and circulated back. This is an edge. Okay. Guys, I think I shall check whether there are some people are waiting. Yes. Okay. Now, now in the condenser, I am I am passing cold water. It is getting heated up because all the heat is rejected. Hot water is passing over the condense over the cooling tower. In cooling tower, I am putting some fields so that the large amount of water and air will come in contact. So because of that, water will get cooled and air will get heated up. Now the cold water will come and again. So this is how the system operates. So it means that in short, the chilling plant has a chiller unit, has a cooling tower, and has a air chamber. Now, if you have a 10-floor building, then one supply will go to first floor, second supply will go to second floor, third supply will go to third floor, and all the supply will come back and this. Right. Now, how to maintain, how to reduce energy consumption in a chiller. Now, let us go back. The chiller compressor power consumption depends on how much is evaporator temperature and how much is condenser pressure. If these two, this is low and this is high, it means this compressor will have to produce less, will have to provide less heat, less power. It means you can assume that the main purpose of the compressor is to increase the pressure from this to this. If it is been already high, then it has to provide less power. If it is already low, then low to high. So as the difference between this is what compressor power will increase. It means that if I supply hot water here, then the condenser pressure will be more. If I supply cold water, then condenser pressure will be less. So it means that I shall maintain this temperature as low as possible, and the difference between this and this shall be low. So that is called as LMTD. So LMTD in evaporator and condenser shall be low. Sometimes it is maintained 0.6. I have seen 0.6 even at some places I have seen 2 to 3 Kelvin being maintained between refrigerant and the water. Okay. Now you can check that these kind of chillers are generally used where your load is more than 80 TR, and the power consumption of this entire system is hardly 0.5 to 0.7 kilowatt. It means that if you have a chiller of 100 TR, it will consume 50 to 70 kilowatt per hour. Kilowatt means 70 units will be consumed in an hour, right? So these are some of the tips which we as an auditor generally do. We put VFD at all the pumps. We select the pump having operating at optimum efficiency. We'll discuss about the pumps in short. Now, I just wanted to give you some case study of one of my study. I found that there was a building of 3, 4, or 4 floor, or maybe 7 floor. On the top, I found they have one fan, exhaust fan, right? So exhaust fan is already placed at different location in a building to remove the unwanted gases from the building, right? Now, when I went up and I found from the exhaust gas, large amount of air is being coming out. If the air is coming out, it means air is coming in, right? Now, now this fan speed is generally kept full, and sometimes so if this blower is running at the maximum speed, then it will try to create maximum vacuum at this place, at this place, at this place, at this place, at this place. So if the vacuum is being created because of this fan is sucking the air, more the vacuum, more amount of air from the cracks, from the opening will try to come in the building. It means that if this fan is trying to create more vacuum, more amount of air will suck. We just said then that try to reduce the speed of the blower by some way so that you don't have to suck large amount of air. Now I don't know from where air is leaking, but certainly air will, I cannot stop the leakages, but I can reduce the airflow, fresh airflow. So if the fresh air is coming less amount of heat will be added required for the chillers to do. Accordingly, AC load will reduce. Right. So that is how we did, and it was possible that around 40 to 50 ton load. Now you can assume that a 40 to 50 ton load, if could be saved, it means around 40 into zero point 0.7. If you do, it will be how much? 28 kilowatt. 28 kilowatt being saved. 28 kilowatt into 20 hours. It will be around 560 units per day will be saved. 560 units into 10 rupees. 5,600 rupees per day will be saved. It means 1.5 lakh to 1.6 lakh rupees per month will be saved. It means 20 lakh rupees per year will be saved just by reducing the blower speed. Can you understand that? The blower speed, so we do audit in doing all setting all this thing here. But what about this flow? So many auditors are not emphasizing at this point. You have you have kitchen exhaust, you have a basement exhaust, you have exhaust at many places, right? Sometimes toilets and bathrooms have exhaust. So all the exhaust are being placed for some purpose, but if it is being used more than that, then obviously it is causing. In some hotels, I have found, not found, it is there that you have a kitchen over here and you have dining room over here, and both are air conditioner. Now, in the kitchen, you have exhaust fan so that whenever he is doing some frying operation, all the exhaust shall be vented out, not being, it shall not affect the customers. Now this fan is continuously running. If this fan is running, it means that all the AC air, cold air is being sucked by this. So it means that at one time, at one place, you are cooling the air, and at second place, you are literally. So if I stand here, you will find cold air is being thrown out into the atmosphere. Right? So revamping of the cooling tower. So as I told, the cooling tower function is to cool the water. So first of all, whenever you are going to check whether the cooling tower is properly working or not, first check whether the water is properly distributed or not, whether you are getting the water in the form of droplets, or are you getting entire lumps of the water being falling down. If not, if it is okay, then you check the water temperature at the outlet of the cooling tower. At the same time, you also check ambient wet bulb temperature. This temperature shall be close to ambient wet bulb temperature. It is not possible that this temperature will be equal to this temperature, but this has to be close to this temperature. It means that if ambient wet temperature is 27 or 28, if it is 30 or 31, you say perfectly okay, there is no need to do anything because cooling tower is perfect. If this temperature is 27 and this temperature is 32 or 35, it means that the cooling tower is not functioning properly, the outlet temperature is 35, it means that through the condenser I am supplying hot water, because of that the compressor power is more. So if you change the cooling tower, or if you revamp the cooling tower and bring down the outlet temperature to close to a WBT, then the compressor power consumption will reduce proportionally. Check the airflow rate at the outlet and fan power. So, in short, the cooling tower shall have lower approach. Approach means this minus this shall be less. Now, AHU. As I told you, the cold water from the chiller is passed over the coil, and the return air from the room is come here, is passed over the coil, it get cold through the blower, it's supplied to the room. Now, all it is not possible that all time I am taking the return air and this thing. Because of that, there will be suffocation. So some amount of fresh air is added. So fresh air plus return air, these two air mix, and then that air passes over the coil and it's supplied to this thing. So this is how the AHU looks into at various places. It has a filter, it has a coil, it has an outlet coil, inside you have a blower. So the air comes, it gets filtered out and passes over the coil, it gets cooled and this thing. Now, what are the measurements you need to do? You need to measure the static pressure at the outlet, because this air has to reach to furthest location, blower's power, measure the air velocity at each place, so that you will know how much is the amount of air will flow. Is if the air flow, if the air velocity is coming less, then you may say that maybe the coil is choked or the filters are being jammed. Then try to reduce the fresh air flow, because fresh air is already been coming through some windows, so there is no need of taking the fresh air from the edge. So it is not all time, but we try to minimize the fresh air load as much as possible. Second, this blower, if it is running at a full speed, it means that the duct pressure is high. High duct pressure is not required. So try to reduce the blower speed in such a way that the air which is coming out from here will reach the furthest location. So that this pressure can be such that if I'm sitting at the furthest corner of the building and my duct is coming up to there, I shall able to get the fresh supply air. Then clean the filters and the coil regularly, so that the blower power consumption will reduce. Avoid wall throttling and minimize air flow rate. Up to here, guys, any doubt? Is my speed okay? Are you understanding?
Yes, sir. Okay.
If you have any doubt by this time,
No, sir.
okay. I think there is no one is ready. So I start. Now, guys, this is something very strange. We generally heat the water by LPG. We at home we require water for hot water for the purpose of bathing. Now, in a home, you have 3 people, 4 people, 5 people, maximum 6 people, depending on the family. Per person, you require 15 liters of or 20 liters of water. It means that for a 5 person, 100 liter water is required per day. 100 liter water, you are not heating up to temperature by 80 degrees Celsius. You want a warm water, so you are heating the water from a temperature of 20 degrees Celsius to 50 degrees Celsius. It means you are increasing the temperature of the water by 30 degrees Celsius. Right. Now, but there are some places like hotels, like malls. In hotel, there are various rooms are available. Now, per room, there may be 3 people or 4 people. So in a hotel, there may be 100 rooms or 200 rooms or 50 rooms. It means that on a, on a daily basis, there are 200 to 300 people are coming to that hotel. If 200 people are visiting, 200 into 20, it means that how much will be the amount? It means 4,000 liter hot water that hotel will require per day. I am just going to give you that. Then that hotel business person calls us and says that, sir, my electricity bill is too high because of water heating application. What shall I do? Then he has an option. Either he can use a boiler operating on the wood, or he can have a, a boiler which is operating on LPG, or he can use electric heater, or he can use a heat pump. What is heat pump? Heat pump is your normal air conditioner, but like this, where your evaporator is being placed into ambient and the condenser coil is deep in a water. Now, for 1000 liter of the water heating per day by a temperature of 30 degree Kelvin, if you use wood as a fuel, then you may require 16.7 kg of wood per day. If the wood is costing 7 rupees per kg, then your expenditure per day for this much liter of water is hardly 116 rupees point 7 per day. But if you switch over to LPG, LPG being a costly fuel, clean fuel, efficiency is higher, but you will, although LPG has higher calorific value, so you will require less amount of LPG, but the cost of LPG is 100 rupees per kg. So it means that your expenditure will go up from 116 to 326 rupees per day for this much liter of water. If you use electric heater instead, and say that I will keep electric heater in each room and I will pay light bill. Then, if we use electric heater, then his electricity consumption per day will be 36 units per units, and if the cost of light is 10 rupees per unit, which is generally higher because in commercial sector electricity tariffs are different. It may be 12 to 14 or 15 rupees per unit. Then accordingly, this light bill will be higher than this much. Now, if you use a heat pump, in a heat pump, 1 ton heat is being taken away. It means 3 kilowatt heat is being taken away. 1 kilowatt I am adding, so I am getting here 4 kilowatt. It means that I am getting 4 kilowatt by putting only 1 kilowatt or 2 kilowatt. It means that if you put 2 kilowatt of the heat, then 5 kilowatt of the heat you are getting here. So it means that 2 kilowatt you are consuming and you are getting 5 kilowatt. Here, in case of electric geyser, you are paying for 5 kilowatt, but in case of heat pump, you are getting 5 kilowatt, but you are consuming hardly 2 kilowatt. It means that your light bill will drop from 36 to 12 kilowatt. It means your light bill will drop from 360 to 120. It means that obviously if you are using wood, it will say that go for wood. But if you are using electric geyser, sure shot you can change from electric geyser to heat pump, and your saving will be almost 1/3. Your consumption will be almost 1/3. So many hotels where hot water is required, even for the cooking of the rice, some amount of hot water can be used directly, and then you can cook the rice after that. Even for uh, uh, your all the foods which you are making, the hot water can be taken from the heat pump, and the further heating can be done on the rest of the equipment. Now, many people has a doubt that what about solar? We have a roof, we have a terrace. Shall we go for solar power? Yes. Earlier, solar power was costlier. The if this is 35 rupees per watt, earlier, a decade ago, this cost was 300 rupees per watt. It means now the price has been dropped by almost 10 times. The 10-time price of the solar PV has been dropped. Because of that, solar PV is an attractive uh, option to use to suffice your electricity demand. So, but people are not aware how much it costs, how much it will produce, what are the economics, how it is to be used. So just I am giving you some glimpse how the solar PV system works. Solar PV can be installed on a terrace or on a land wherever you have a place. The power produced from the solar panel is DC nature. But for the home appliances, you require AC power. So you require an inverter. Inverter is a device which converts DC power to AC power. Now this AC power can be directly used for your home. No, then the excess power will be fed to the grid. That is called as net metering system. Now, you have consumed in a month, suppose 1,000 unit you have consumed, and 1,000 unit you have consumed, and you say that boss 1,000 unit I have consumed, but I have given you 500 units. So the MACB will say that okay, then 500 units which you have given to me, I will reduce from your bill and I will charge you only for 500 units. It means your earlier bill, which was for 1,000 units, 1,000 into 10 rupees. So 10,000 rupees, suppose, was the bill coming per month. Now it will come 5,000 rupees per month because of the net metering. But a net metering option is not given for a large capacity system. So there people are purchasing the land, and from the land they are producing the power and giving to grid. Let us have some economics. So let us assume that I have a land. Guys, can I use Excel sheet? Okay. Suppose I have a land having area 100 meter square. 1 meter square on I can have 1 kilowatt per 10 meter square. It means that I can install how much kilowatt? I can install maximum 10 kilowatt of 10 kilowatt panel. One panel gives me 4 units per day. 4 into 10. It means that panel, 10 kilowatt panel, will generate 35 to 40 units per day. 40 units per day will be generated. Right? The getting point? Now, 40 units per day, 40 units into 365 average wise. So 14,000 units will be generated per year. Right? So 10 kilowatt panel, right? So I have a land area of 100 meter square, 10 meter square per kilowatt is the area required. So I can have a load of 10 kilowatt this much. Now the cost per kilowatt is 40,000 rupees per kilowatt. So it means that you have invested how much? You have invested 4 lakh rupees. And if you are able to save this much units into, suppose 5 rupees is the cost of unit, it means 73,000 rupees per year you are saving. So this divided by this, within 5 years you can recover your cost. But if you are getting a net metering system, then light bill you can recover your cost within 3. So guys, same thing I have put it here. For 1 kilowatt, the area required is approximately 9 to 10 meters square. 1 unit panel will produce 3.7 to 4 units per day, and the cost per kilowatt will be 35 to 40,000 rupees. So, if you have installed a solar panel of 50 kilowatt, then we require approximately 500 meters square area. It will generate 70,000 units in a year, and then suppose if the light bill is coming 10 rupees per unit, you can save 7 lakh rupees per year or 0.58 lakh rupees per month, and the cost of system will be 22 lakh. So within 3 years, the whole cost, whatever you have incurred, will be recovered. Now, the life of the solar power plant is generally 20 to 25 years. It is been said. No one has tested because nowadays only from last 10 years, solar power plants are generally being used in large number. Even though after 25 years, it has been said that the power production from the same panel, if you have a panel of 50 kilowatt, it may generate 40 kilowatt. It will not be zero, it will be 40 kilowatt, which even after 25 years, a power production will be reduced by hardly 20%. Now, let us come to a pumping. Yeah. Okay. Okay. I will take this question at the end. Right. Is it okay? Okay.
Okay, sir.
Okay. I just note down that the question is there. Otherwise, I may forget. Right. See, now, in a flat, suppose you have 112 flat, something number in your building, and if you feel that in each flat there are 4 members are staying, so total 448 members are there in a complex. Let us assume that one person requires 120 liter of the water per day. Just number. It means that society is consuming around 53,000 liters of the water per day. Let us assume one floor height is 4 meter. It is not possible, but 4 meter is, I am assuming. Now, you may say that, sir, 4. So let us assume that the height from the water tank to the sump level, if suppose it is 36 meter, and there are other losses in the pipe bends and velocity losses, friction losses. So it means that it means that the total head required by the pump will be 40 meter. It means that when the amount of the power required by the pump, minimum power which will be required will be 5.9 units. So that pump will consume minimum 5.9 units per day. Now, if you have chosen a pump having efficiency 40%, then the power consumption and the unit consumption of the same pump will be 14.7 units. It means that a selection of the pump having large efficiency will be better. If you have chosen a pump costing less but having less efficiency, then you are paying over the entire life of the pump than saving at once. Now let us see pump's energy consumption. Now you can see that a pump energy, the efficiency of the pump is maximum at a given point. However, if you operate the pump at any other point than the best efficiency point, then efficiency will be less than this. So the efficiency could be as good as 90%. If you operate at this point or at this point, efficiency will be 60 to 50%. Now, this may be possible. This may be possible because of not the wrong pump, because the system you have a drop. A system has flaws because system piping are not appropriate. Piping size is not appropriate. Pipe has too many bends. Pipe has too many walls. Pipes are not being cleaned. Because of that, the head, operating head of the pump may shift. So, first of all, choose an appropriate pump which will suit to your system requirement. Second, try to operate the pump, try to select the pump so that it will operate at its best efficiency point. Avoid wall throttling. Choose a line size of larger size so that the operating head will be less, so that the pumping power required will be less. Now, these are some of the things which is not a part, but just saying that the pump power consumption, these are the curve which says that the power consumption of the pump. So the power consumption of the pump depends on which are the operating point. Let us see. Let us take example that you have chosen a pump having cost less, but operating efficiency 35%. Suppose the building is required 100 liters of the water per day and the head is 25 liters. And the light bill is coming 10 rupees per liter. In that case, if you have chosen a pump of 35, having efficiency 35%, having 35% efficiency, then 75% efficiency, then per year your light bill will be increased from 33,000 to 71,000 rupees. It means that in total 40,000 rupees per year you are paying excess. So if you have chosen the pump, this pump is costing 50,000 rupees, this pump is costing 30,000 rupees, 20,000 rupees you have saved. But now 40,000 rupees per year you are just paying to electricity bill. So it is better not to overlook a pump which is used in the society. Now, there is an important phenomenon of a light bill. There are two factors which are normally used in electricity. Let me show you. What happened? Okay, I just give you some example. There are some terms called as kilowatt and kVA. We know that voltage into current is power, right? But this is wrong. Voltage into current into power factor is actually power. VI cos phi is power. In case of single phase, this equation applies. In case of three phase, root 3 VI cos phi is power, is watt. Right? Now, voltage has a unit of V, current has a unit of ampere. Right? So this becomes voltage ampere. But if it is a kilovolt, then kilowatt. It means that kilovolt ampere into power factor is kilowatt. Right? Now, earlier it is, you have suppose a load. Then this load will consume kilowatt, not kVA. It will consume kilowatt. Now, this load has suppose some kilowatt, let us say 10 kilowatt. Suppose this motor has a power factor of 0.5. The power factor, if it is 0.5, it means cos phi is 0.5. If cos phi is 0.5, it means phi is 60 degree. It means this is 60 degree. Now, this is your KVA. It means if the power factor is being, suppose the power factor, let us say power factor as 1. If power factor is 1, it means cos phi is 1. It means phi is how much? 0. Then in that case, KVA is equal to KS. It means more the power factor, less will be KVA. So it means that if you have a complex, here you have complex, here you have complex, here you have complex, and here you have a common transformer. You have common transformer. Now this building has a load of 100 kilowatt. This building has a load of 200 kilowatt. Suppose its power factor is 1. Its power factor is 0.5. It means its KVA will be how much? 200. Right? And its KVA will be how much? 200. Because this is this. It means that this requires 200 kVA. This also requires 200 kVA. Right? Now, this has a load of 100 kilowatt. But he said that, boss, I want power. He said that my power transformer is of 400 kilowatt kVA. So I can match here, I can match here, I cannot provide it. But now, if this person increases its power factor from 0.5 to 1, its demand will reduce to 100 kVA. It means this is 100 kVA. Now 100 kVA extra, I can provide 100 kVA to this. So now, the person who is distributing power, he says that because of you having less power factor, I cannot meet my demand. I cannot build this plant. So I put a penalty to you. He said, okay, I have no objection on penalty. He said, no, now I will not charge you for 100, I will charge you for 200. So earlier he was charged for 100, now he is charging for 200 because of power factor. इसका example देखेंगे. You are a person who is taking a milk, but sometimes you take 1 liter, sometimes you take 2 liter, sometimes you take 3 liter, sometimes you take 4 liter, sometimes you take 5 liter. The milk person every day bring 5 liter milk, right? Sometimes you take 1, 2, 3. So at the end of month, you are billing him from 1 plus 2 plus 1 plus 2 plus this total maybe 50 liter into 60 rupees, you are paying 3,000 rupees. But now he says that, madam or sir, you are taking 1 liter or 2 liter, but I have to carry 5 liter. You take or not, I am going to charge you for 5 liter. So 5 into 30, straight away 150 liters I will charge you, irrespective you use or not. Now this person will say that no, now I don't want 5 liter, I want 2 liter. So the power factor which was earlier 1 by 5 or 2 by 5 or 3 by 5 or 5 by 5, 1. Now power factor is improving. Power factor is improving, and now, so earlier the billing was KWH, now billing is KVAH. So electricity nowadays is charging you on KVH, not KWH. Because of that, the power factor, if it is being more, you are not being penalized for less power factor. Understood, guys? So
Yes, sir.
If you have a power factor of 1, then your bill may be 21 lakhs. Otherwise, your bill will be 23 lakh if your consumption is this much. Okay, so the power, as I have told you, the power can be measured by VI cos phi or root 3 VI cos phi depending on single phase or three phase. In industry, three phase motors are largely used as compared to three phase. Single phase you will find rarely in industry. So the power factor would be cos phi, or you can say kW into kVA into cos phi, less the power factor, more will be kVA. So earlier electricity bill was into kW, now the electricity bill is kW. It is for industrial, heavy commercial, but for residential, why it is still kWh? Everybody knows that the vote bank is weak, so government can't put a restriction on us normal voters. Now, let us assume that if the motor having a load of 20, earlier its load was 20 kilowatt and power factor was 0.8. So kVA will be how much? 25. Now that motor's power factor has been improved from 0.8 to 0.95, so the kVA rating of the motor has reduced from 25 to 20. It means that if suppose 8 rupees was charged, then that person will save 25. He was paying for 25, now he will pay only for 20. It means he will save for 4.6 kVA. 4.6 kVA into 8 into 24 into 365, so 3.21 lakh rupees per annum he was able to save just by increasing the power factor of this motor from 0.8 to 0.95. Clear, guys? Similarly, if you are able to reduce the electricity load of some motor by replacing or by energy audit or done, then if you are able to save 5 kilowatt, as I told you, 5 kilowatt into 24 into 365 into 8 rupees, 3.5 lakh rupees per annum you can save, which is a normal salary of a common man. That is, these are just thing I am just trying to say you how the power factor can be improved. Power factor can be improved by putting a capacitor bank. So this is in earlier case, this was by reactive load. Now, as much reactive load I wanted to reduce, that much capacitor bank I have to provide. So capacitor bank capacity has to be decided how much I do. If I have to reduce it fully, then this much capacitor bank is required. So these are the incentives being given by state government. If you are maintaining a power factor of in the range of this much, then they give you large incentive in your bill that thank you, because of your less power factor, more power factor, we are able to use our capacity to the maximum possible extent. Now, some light bills. You can see there are tariffs are available. Tariffs for the residential purpose for 0 to 100 units, you have less charges. But if you increase the electricity consumption more than 300, the tariff increases from 3 to 6 rupees, and above 500, this goes to 7 rupees, 7.8 rupees per unit. Similarly, the fixed charges also increases, and billing charges with the power which is between this plus this will be your electricity charges. This plus this charges. In case of commercial, light bills are being charged based on the contract demand and the energy consumption. Again, they are also giving the incentive for at what time you are using electricity. If you are using during the peak time is what? Evening 6 to night 10 o'clock. At this time, they are actually charging you 1 rupees excess than the normal tariff. But if you are using a light electricity during a night time, that time everybody's lights and fans are, or everybody's load is mostly off. lights are off. So the power plant has less consumption. So they say that if you use a light during this time, then whatever electricity bill will be there, in that my rates will be less by 0.75 than this. It means that if you have a residential complex, tell your uh, or security guard that try to use the pump during night time, so that whatever electricity being consumed, the tariff applicable to that time will be 0.75 less than whatever the normal bill. Okay, now selection of the fuel, one of the most important thing for mechanical engineers to be known. We feel that LPG, use of LPG, NG, LDO is the best fuel. These fuel are good fuel, are clean fuel because they have higher calorific value. They have good efficiency even. Burning efficiency of this is even better. But if I to compare how much I am getting heat per rupees, then they are actually expensive. Let us compare. If you use an LPG calorific value is 11,500 kilocalorie per kg. And if you burn the LPG in a burner, in a boiler, then the burning efficiency and the efficiency of the system may be 85%. It means that 11,500 into 0.85, that much net amount of heat I got. And 1 kg of LPG is costing me 100 rupees. It means by paying 100 rupees, I got this into this. It means in 1 rupees, this divided by this, I got only 98 kilocalorie per rupees. Same thing, if I compare for natural gas, I am getting little bit higher amount of heat per rupees. For LDO still higher, for FO still higher. Now, if you compare with light electricity, 1 unit if you consume, then you are getting only 860 kilocalorie. And efficiency of the geyser is 95% because there is no loss from the geyser. It means that 860 kilocalorie I am getting for 10 rupees. It means 81 kilocalorie I am getting per rupees. Now let us compare with coal. Coal ka calorific value is less. Efficiency is poor. But the rates are 14 rupees. It means in 14 rupees I am getting 5,000 kilocalorie into 0.7. It means 3,500 kilocalorie or less. 3,000 kilocalories I am getting at 14 rupees. It means 275 kilocalorie I could get by paying 1 rupees, which is almost double than LDO or 2.5 times more than this. It means if I spend on coal same amount of rupees, I will get less amount of heat, but here I get more amount of heat. Similarly for briquette, this is. So guys, don't feel that the coal or briquette, many industries are still opting for coal and briquette because it is much less costlier fuel as compared to LPG. Okay, so thank you for your patience listening. Now question answer. So first of all, I have one question about the solar panel which is asked by Abhishek. Let me answer that. Solar, the PV system, the cells are being packed into a toughened glass, and it is being sealed properly so that water will not leak into the panel side. Number one. Number two, yes, because of the dusting, the power production from the solar panel will reduce. But the power production from the solar panel will reduce by 4 to 6%, not 100%. So even though you are not going to clean the panel for the entire year, the 100 kilowatt panel will generate at least 94 kilowatt. So 5 to 6% or 10% power will reduce. Yes, it requires a periodic cleaning. A, a cleaning can be done by water sprinkling, or there are robots nowadays being made. Even in our college, we have developed a mechanism which can clean the panel automatically by brush, water, and wipe. So there are various mechanisms are available which can clean the panel regularly. Yes, in rainy season, the power production uh, from the panel will reduce. So as I told you that 4 units per day, it's an average of the year. It means in summer, 1 kilowatt panel can generate 5 to 6 units, which is zero in winter or in rainy season. So average, which I told you, is over the year. So if I say that one panel is generated, suppose 100 kilowatt in a month of the summer, and for the rest of the year it is produced nothing. So 100 divided by 365, the average is 0.3 kilowatt per kilowatt is the average. Right. So whatever numbers are being coming are actually based on the or the year, not based on the actual operating condition. I hope I answered. Okay. Any other doubt?
Yes, sir, I have one more doubt. Uh,
Okay.
so, what if we have the access to wind energy abundantly in our house? Like, if our house is in the farmland somewhere
Hmm.
in our village, and if we have abundant wind there, so what
Hmm.
if we install wind panels on the rooftop of our on the terrace of our house?
Hmm.
So, which option is better, wind power or solar power
Okay.
in that scenario?
Okay. First of all, the word we have large, we have more, we have plenty. These words shall be avoided as an engineer. There is a feasibility thing which we have to first carry out. Feasibility study compromises of they check that at your location what is the average wind velocity over the year, how it varies over the night, over the day, over the season, and whether it is and at what velocity you are getting the wind power. Then, based on that wind velocity, then the height up to which you can install the wind fan. Suppose you are coming to some number that for my application, 1 kilowatt, 2 kilowatt, 5 kilowatt, 100 kilowatt windmills is sufficient. You have to understand that whatever is the power is not generated, power is being consumed, right? Power, if being consumed, then only it will generate. You cannot say that a windmill is there, it is rotating at a higher speed, so it is producing large power. Unless it is connected to a load, power cannot be generated. Otherwise, its speed will be very high. Okay. Now, once you are able to decide that I am going to install a wind turbine power plant of 1 kilowatt or 2 kilowatt, you can install at a building. But now the structure of the building has to be taken care of because the wind, there is a effect of the stress being happening on your building because it will act as a cantilever. Then because of that, you may find some kind of cracks or this thing. So you have to have an additional structure for installation of the wind power. Then the cost of the wind power. Then whether now here in case of solar, I can say that 1 kilowatt panel will generate 3 to 4 kilowatt of the electricity of 3 to 4 units per day. In case of wind turbine, I can't have any number because that depends on the for the whole day there may be wind, for the whole day there may not be wind. So that number I cannot say it may be zero, it may be 24 units per day even. So now So according to depending on the how much electricity will be generated in a year for a given location, and then what is the costing, and then so if I say that your wind turbine power plant, it can 1 kilowatt power plant you have installed, and you say that's a per day 10 kilowatt per day, 10 days 10 unit it will generate. I have checked. So 10 into 300, even if you assume, so 3000 units it is generating in a year. 3000 into 10 rupees, so 30,000 rupees per year is your saving. Now, what is the cost of wind turbine? You can check. There are various sites are available. So then, how much will be payback period? Accordingly, you can choose to go for or not. Yeah.
Okay, sir. Yes, that cleared my doubt.
Yeah. Any other question? If no,
So, what do you think are electric cars really a solution for conservation of energy in
okay.
India?
Yeah, electric car, electric. See, there are two types of engine. One is IC engine, which is normally used in our vehicle, and there is an electric car. Now, if you see an IC engine efficiency is 30%. Efficiency of engine is 30%. It means that whatever the amount of energy I am actually putting into the engine is 20 to 30% is converted to the actual use, and remaining is being uh, waste into the flue gas and into the air. Guys, 1 second, I'll just sorry. Okay, now and that too 20 kilowatt. Suppose you have an engine. Now you can assume that the car consumes 10 to 15 kilowatt load. It means that now the 15 kilowatt load is required for gears, for clutch, for engine operation, for so many things. Now electric car has already removed those components. So the load of the car has been dropped from 15 to maybe 10 or 8, number one. Number two, the electricity being or the load, or what I'm saying that whatever is the load being actually required for a car, if I if I consume the same amount of fuel into a boiler or into some application, then there my power plant efficiency can be even 30% or 40% because those are large power plant. So the same amount, the fuel which here I'm wasting. So here let us assume that I am consuming 100 liters of the diesel. From 100 liters of the diesel, I can generate maximum 300 units. From 1 liter diesel, I can generate maximum 3 to 4 units. So, but in case of IC engine, which is used for our car, you can generate maximum 200 units. So, ek to on one side you have burned 100 liter of diesel, and you have produced maximum 200 units. Now, if I burn the same amount of diesel in large power plant, there I can produce even 400 units. Now, 400 units, here I can run 10 cars, now I can run 20 cars. It means same fuel, it means almost half of the fuel is being saved because of my changeover. It is now secondly that I have a solar power. So if I'm able to install solar power plant, and I can generate the power. Then why shall I burn the fuel? I will use electricity. The time may become in a downtime, maybe down the line, maybe 10 years after, you may find that all the IC engines may be obsolete because these IC engines are the major consumer of the diesel and the petrol. Second, if India is going to install more and more solar power plant, even if tomorrow we want that our all energy needs to be met by only solar, we don't want to import even a single drop of oil for any purpose. We just need to install we just have to install solar power plant on 1% of the land. How much? 1%. So India का 1% land भी use किया for the solar power installation, then the power demand of the India can be made only from solar. That much solar energy has a potential to meet the energy demand of India. Yeah. Any doubt?
No, sir.
Okay. Thank you guys for patient hearing.
Rishabh?
Okay, sir.
Hello. Should I begin with the vote of thanks then, guys? Hello.
Yes, Rishabh.
Yes, Rishabh.
Okay. So good evening, all. I, Rishabh Naneshwar Shelar, deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all thank the Almighty God for making today's occasion an astounding success. First and foremost, I would like to thank our speaker for today's session, Dr. Yogesh Padia, who, despite his busy schedule, has found the time to grace this occasion. The comparison of various examples and factors of electric consumption gave us an exciting overview about the topic. Also, on behalf of everyone present here, I would like to thank our principal, Dr. Prasanna Nambiar, for supporting us for this session. My heartfelt thanks to all the head of departments and faculty members for their valuable contribution, guidance, and encouragement in all our efforts. I thank all the invitees present here today who tuned in with us via YouTube live stream, who accepted our invitation. Last but not the least, I would like to thank you, my friends, for your cooperation in making this event a resounding success. Once again, I thank you all for your attention. God bless all. Thank you.
Thank you guys.
Thank you, sir.
I request
Thank you, sir.
everyone to please fill the feedback form. It is in the chat box. Please.
Okay.
I will also share the feedback form in the WhatsApp groups. So thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Shall I close the meeting?
Yes, sir.